Good morning, dear. I hope all of you are healthy and fine. Today we will correct together our homework, which was about solving extra exercises. So please put your homeworks in front of you and follow with me. Number 1. EGH is an equilateral triangle. What do you mean by equilateral triangle? It's a triangle that has three equal sides and three equal angles, each one of them equals to 60 degrees. EGH. It's an equilateral triangle, so EH equal to HG equal to GE. And all its angles are equal. The sum of angles in triangle is 180 degrees, so 180 divided by 3, each one of them will be 60 degrees. Then, F is the symmetric of G with respect to H. What do we mean by that? It means that H is the midpoint of FG. Here, this is F. How can we draw it? It's symmetric of G with respect to H, so we measure the length of HG and then draw a segment of equal length on the opposite side, and at its extremity we will call it point F. Again, F is symmetric of G with respect to H, then H, the letter which comes after with respect to H, is the midpoint of FG. Now, the question is to verify that EHG equals to 120 EHF. This angle equals to 120 degrees. To think correctly, here we have EHG and equilateral triangle. So each of these angles is equal to 60 degrees. Here we have EHG equals to this angle EGH equals to GEH or HEG equals to 60 degrees. Okay, then what about this angle EHF? If I look well, FHE and EHG are adjacent supplementary angles, so their sum equals to 180 degrees. So to find the measure of FHE, we will say that it's 180 minus 60, which is 120 degrees, and that's how we verified it. When they ask me to verify, then my answer will definitely be as given. They are telling me that this is the measure of angle EHF, but I have to prove it, and that's what we did here. Now, number 2, prove that EFG is a right triangle at E. EFG. This is a triangle. It's right at E, so I have to prove that FEG equals to 90 degrees, but HEG equal to 60. To prove it, 90, here FE perpendicular to EG, forming a right angle, which is FEG equals to 90 degrees, I have to prove that angle FEH equals to 30, since 30 plus 60 equal 90. How to find the measure of this angle FEH? I have to say that HFE is an isosceles triangle. Why? Since given that FH equals to HE. Look, the same sign is put at FH and HE, so it's a hint that they are equal. So it's an isosceles triangle. And we know that the base angles of isosceles are equal, so HFE should be equal to HEF. But what's their measure? Again, the sum of angles in a triangle is 180. So 180 minus 120, all must be divided by 2, since I'm finding each one alone. Or you can say that 180 minus 60 equal 120. Point on the new line, HFE equal to FEH equal to 60 over 2. The both ways are correct and will give me the same result, which is 30 degrees. Now, I proved that FEH equal to 30 degree and HEG equals 60. Their sum is 90 degree. Since FEG equals to 90 degree, so clearly I can say that FEG is a right triangle at E. It's easy, but I have to concentrate well. Now number 2, PSA is isosceles at P. Let's start by drawing the side. SA equals to 4 cm. This is SA 4 cm. Then PSA is the angle of vertex S, so I have to put here the origin of the protractor and draw an angle which is 54 degrees. Again, PAS equal to 54, so the angle here SAP equals to 54. The point of intersection of these two rays is the point P. Now, R is symmetric of S with respect to A, so A is the midpoint of RS. When I talk about symmetry, then I have to draw AR. What's the length of AR? R is symmetric of S with respect to A. It means that A is the midpoint. So since SA equal to 4 cm, then AR equals to 4 cm. Now, the bisector of PAS cuts PS at E. The bisector is a semiline that cuts the angle into two equal angles. This is angle PAS. This is the bisector of angle PAS. It cuts or intersects with PS at point E. How to draw the bisector? By two ways. Either I should find the measure of angle PAS, which is 54, and the bisector divides the angle into two equal adjacent angles. So 54 divided by 2 equals to 27. So at the 27 degree, I have to plot here point E and find that EAS equals to 27 degree. Or the other way is by using your compass. I have to put the needle on the vertex A, draw an arc on PA, draw another arc on AS without changing the radius of the compass, and then put it at the point of intersection with the arc on the side. Draw another arc, and similarly from PA, the intersection of these two arcs will form with the vertex, the bisector of PAS. It's up to you. You can solve it the way that you prefer. Then I have to draw the bisector of PAR that cuts PR at point F. When we draw the bisector of PAR, the point of intersection of this bisector with PR is called point F. Now I have to prove that AEF is a right triangle. You have more than one method to prove. I can say that by calculating angles, since AE is the bisector of SAP, so it divides the angle into two equal adjacent angles. So SAE equal to EAP equal half the angle of SAP. So 54 divided by 2 equals to 27. Now, what about here PAF and FAR? Also the same way, since AF is the bisector of angle PAR, so PAF equals to FAR equal to, what's the measure of this angle? I don't know, but I know that these two angles are adjacent supplementary. So it's 180 minus 54. And I have to divide it by the answer by 2 to find the measure of each angle. So 180 minus 54 divided by 2 is 63 degree. Now EAP equals to 27 degree and PAF equal to 63 degrees. So if I add them together, I will get EAF equals to 90 degree. And since we find a right angle, then I can say that EAF is a right triangle at A. Another method to prove by using the properties of the bisector. The bisector of two adjacent supplementary angles are always perpendicular. That's a rule that we should memorize. So here we have SAP plus PAR equals to 180 degree. AE is the bisector of angle SAP, and it's the bisector of the first angle. And what's the bisector of the second angle, PAR? AF is the bisector here. It's the bisector of PAR. So AE is perpendicular to AF at A. Then I can say that EAF is right at A. Okay, the both methods are correct. You can choose the one that you prefer. Now number 3, a triangle ABC such that BC equals 6 centimeter. We draw it. Keep in your mind that we always start from the ruler, from the 0. Okay, not from the edge. Then ABC equals to 80 degree and ACB equals to 55. We draw angles by using the protractor. The perpendicular bisector of AB cuts AC at H and AB at I. Starting here, the perpendicular bisector of AB, so I have to draw the perpendicular bisector of AB. It's a line perpendicular to AB at its midpoint I. So the first step is to plot the midpoint I and draw a perpendicular, or simply by using your compass. Okay, it cuts AC at H. Here we elongate our line so it intersects with AC at point H and AB at I. I have to prove that BAC, this angle here equals to 45. In triangle BAC and in any other triangle, the sum of angles is 180. We know two of its angles, so I have to find the third one. How? BAC equals 180 minus the known angles, which is 80 and 55. So it's 45 degree. It's verified or proved. Now show that IAH, this triangle here, and HAB are right isosceles triangle. Okay, what about IAH? Since IH is the perpendicular bisector of AB, so definitely HIA equals to 90 degree, and the triangle HIA is right at I. But how to prove it's right isosceles? Up till now we proved it's right. What about the sides, IA and IH? No one told me that they are equal, so let's move to angles. From the first part, we verified that BAC equals to 45. And I told you that it's perpendicular bisector, so definitely HIA is 90 degree. Now let's find the measure of the third angle, which is AHI. Always the same rule, the sum of angles in a triangle is 180 degree. So AHI equals to, since these angles are complementary, I can say directly it's 90 minus 45, or you can say it's 180 minus 90 plus 45. The same. And both ways will give me the same answer, which is 45. But here, since we have IAH equals to 45 and IHA equals to 45 degree, that means that these two angles are equal. So I'm talking about an isosceles triangle. These are the base angles. So AH is the base and the main vertex of IAH is I. Now let's move to the other triangle, HAB. I have to prove it right isosceles. HI is the perpendicular bisector of AB. So HA equals to HB. Why? Because any point on the perpendicular bisector is equidistant or having the same distance from both extremities of the segment AB. So HA equals to HB. Then I'm talking about an isosceles triangle. I have to prove it's a right isosceles triangle. So I have to prove that AHB equals to 90 degree. How? Since we have two equal sides and we are talking about an isosceles triangle, so the base angles should be equal. HAB equal to ABH equals to 45 degree. Okay, what about angle AHB? It's 180 minus 45 minus another 45, or I can say 180 minus and put in a bracket 45 plus 45. Again, it's correct. Okay, so HAB equal 180 minus 90 equals to 90 degree. So I'm talking about a right triangle and we proved it isosceles. So clearly I can say that HAB is a right isosceles triangle with main vertex H. Please write the answers on your classwork copybook. They are important for the exam. Thank you for your attention.